Hi, I'm Ryan Baker, and this is Big Data in Education. Welcome to Week 4, where we'll be discussing knowledge tracing and other forms of knowledge modeling. Today we'll start with knowledge tracing. The goal of knowledge tracing is measuring what a student knows at a specific time, and more precisely, measuring what relevant knowledge components a student knows at a specific time.
What's a knowledge component, I hear you cry on the forums? Well, a knowledge component is anything a student can know that's meaningful to the current learning situation, which might include skills, knowledge of facts, knowledge of concepts, knowledge of principles, knowledge of schemas. If you want to learn more about knowledge components, you can go to this link here on the learnlab.org page. Basically, anything a student can know can be a knowledge component. Knowledge inference, it's worth mentioning by the way, is also called latent knowledge estimation sometimes. Worth knowing that term because you'll see it sometimes. Latent stands for not directly measurable, so in the student's head. Now, why is it useful to measure student knowledge? Well, enhancing student knowledge is the primary goal of a lot of education, and if you can measure it, you know whether you're making it better. And if you can measure it, you can inform instructors and other stakeholders about it. And finally, if you can measure it, you can make automated pedagogical decisions. The system can say, I don't think you're quite ready to move on. This is different than measuring performance. In the first 3 weeks, we discussed prediction models. You can use prediction models to determine if a student will do well on a future test. And you can use prediction models to infer if a student's performance right now is associated with successfully demonstrating a skill.
Now, this is different than measuring performance. What we're doing here is inferring if a student's performance right now is associated with successfully demonstrating a skill, which is not quite the same as knowing whether the student has a skill, which is not directly observable. For example, maybe they appeared to demonstrate a skill without actually knowing it, which is typically called guessing. Or, by contrast, maybe they appeared to not demonstrate the skill despite actually having it, which we often call slipping.
So how do we get at latent knowledge? We can't measure it directly, it's latent. We can't look directly into the brain. Yet. But we can look at performance. And we can look at performance over time, which is more information than performance at one specific moment. At any one given moment, you might guess or slip, or appear to. But over time, you can kind of get a pattern and see, is the person's behavior generally consistent with them knowing it? This is not trivial. It's a research problem with a long history, back at least 50 or 60 years.
So this week, I'm going to cover some of the key approaches for knowledge tracing within educational data mining. First up, the classic, the one that people typically use in the largest number of learning systems, Bayesian knowledge tracing.